Well, when people think of Oregon, they think of the Oregon coast. And when you think of the Oregon coast, you think of sand. The fact is, the coast of Oregon is about 310 miles long. And just a little under 50%, 40-something percent has sandy beaches. And the terrain is very, very low. So if there's sand on the land, it has to come from somewhere. And of course that sand came from the erosion of mountains over millions and millions of years, and rock being broken up and carried by the rivers out into the ocean proper, the Columbia River, Siuslaw River, the Umpqua River, Coquille, all basically ended up with a bunch of sand out in the ocean. And then, of course, it needs a mechanism to move inland, and that mechanism is our weather. Now, given that almost half of the topography of the Oregon dunes are flat, there's really not that much in the way of cliffs. For much of the stretch of the Oregon coast, the topography is another reason that sand can form the dunes here. We have a situation in Oregon, west coast in general, or winds come out of the west. That's the prevailing winds come out of the west in general. In the summertime, summer is the season of sand movement more than winter, because the sand is light, it can move, and the winds are stronger in some respects. In the summer, the Willamette Valley heats up, and a lot of the air rises, and it forms a situation where that vacuum needs to be filled, and it's with the winds that blow off the coast, and they move inland into the valley. So you get this west to east wind movement, and the fact that a high pressure system dominates off the Oregon coast as well. And so you get a nice northwest flow of wind moving sand onto the beach from the northwest to the southeast. So the direction of sand movement in summer is different than in winter. In winter, you have big storms. The weather systems tend to come out of the southwest. So the wind, while more vigorous, the sand is wet. It doesn't move as far, but still it moves enough for dunes to form. In the winter, the faces form from the southwest to the northeast, and in the summer they form from the northwest to the southeast. It's just the opposite. So you have this intersection of dune shapes. There's no real consistency because of the weather patterns.
Why don't you get dunes down in California? Because they still have that sand.
You do. As a matter of fact, there's 4 dune sheets, is what they're called, off the coast of Oregon. The first one is actually about 55 miles north of the Columbia River. And you have dunes up in Washington. So from north of the Columbia River to Tillamook Head is a dune sheet that's pretty significant, but it's pretty broken up too. And then from Tillamook Head to Heceta Head is the other dune sheet, but there's also a lot of rocky outcroppings, but you have sandy beaches. And the largest one by far is the dune sheet from Heceta Head down to Coos Bay. And that is really the Oregon Dunes National Recreation Area. And then the 4th dune sheet goes from Cape Arago to the California border. So I think a lot of it has to do with the fact that there have been active rivers that carry a lot of sand here, and because of that there's a lot of sand that is available for movement.
So we just have more erosion occurring because of the higher rainfall and
the Cascade Range, and you have the Cascade Range, you have the Coast Range. So the erosive potential, I believe, is a lot more for putting sand out into the ocean.
Right, because what's coming off of the Sierras is generally going into the Central Valley and south. It's not actually going all the way up
to the ocean.
Okay, that makes more sense.
Yeah, and of course here, with the winds being so strong and the waves moving sand from the ocean up onto the beaches, it was wind that would blow the sand inland. And prior to 1900, there was massive amounts of sand that were moved inland. And it became a problem because as more humans moved into the area and settlements were formed, there was there was a need to stop the sand from moving. In the 1930s, the sand would be so bad it would cover Highway 101. The mouth of the Sayusla River would move a mile north or south, creating sandbars which were hazardous for boat navigation. They didn't know where to go. So they wanted to stabilize the sand in the early 1900s. So they brought in European beach grass. Okay. Ammophila arenaria. Ammophila means sand-loving. This stuff grows in sand. I believe it was actually used in the British Isles to stabilize dunes. And so they grew it. They grew it right along the shore. The idea being that it would bind the sand and stop it from moving. And it did such a good job over the last 80, 100 years. It created this thing called the foredune, which is the big dune right up against the beach. The foredune grew and grew and grew, and the sand stabilized such that it became so high, up to 25 feet, that over time the wind would blow the sand, but the sand stacked up right along the shore, creating the foredune, and over decades sand couldn't move in at all. And so if you walk along the beach, there's always this big wall of sand. That is the foredune created by the planting of beach grass. And because they wanted to accelerate the growing of beach grass, they also planted Scots broom and Portuguese broom with the beach grass. And you can see the yellow blooms of the Scots broom out here. Of course, they're nitrogen fixers. They wanted to provide nitrogen to the beach grass, and so that further enhanced the growth. So as this foredune grew, the wind still blew, and the sand was prevented from moving inland. It just built the foredune up. But the winds went over the foredune and blew the sand on the east side of the foredune and kept moving it inland. And what that did was removed enough sand that it dropped the water table. And water was more available right behind the foredune, and what started to grow? Plants. And now we have this amazing brush band. If you look at topo maps from the 1950s and 60s, when a lot of them were made, there's no brush band on the map at all. It just shows dunes.
So this brush band was completely created by the beach grass.
It was created by the planting of the beach grass, which created the foredune, which prevented the sand from blowing inland. But the wind moved the sand on the east side, eastward still, dropped the level of the sand behind the foredune, raised the water table, making water available for plants, and now we have the plants of the foredune: Sitka spruce, shore pine, salal, huckleberry, a lot of things like that. So basically the brush band is here. There's very little sand that can move inland now, and at best what you're getting is the sand that's here, like this dune here. The sand moves, but it's not being replenished. So human activity has been largely responsible for the demise of the dunes as we know it. Geologically speaking, over time, the amount of sand was diminishing anyway, so less and less sand would have blown up, but the dunes still would have flourished. But now they're dying, and here we are, the northern reaches of the Oregon Dunes National Recreation Area. And the dunes aren't as large as just 20 miles to the south, where you have the eel dunes and you have huge sand dunes, and it's really probably the best example of large dunes on the Oregon coast. But those dunes move inland. If we were to hike up the hill behind us here, this sand is still moving from winds, and it's moving over top of the trail that heads out to 3 Mile Lake. You probably remember that section of trail where the sand is overgrowing the trail. It continues to overgrow the trail because there's still enough sand with, especially the summer winds when the sand is really light, it just crests over and fills up the trail, and the trail keeps changing. So the plants that grow here really are, obviously European beach grass is a very interesting plant, because if you were to rip it out, it would snap off. And where it snaps off, it can grow from the sides. It can root out and grow from where it's snapped off. So the roots on these can be tens of feet long. If you were to pull one of these out, if you could trace the root, it could probably be from the top of the hummock here all the way down, and you would find it 15 feet later, because as the sand rises and covers over the beach grass, it just keeps growing up. It doesn't ever die. So it has changed the topography, stabilized the sand, and stabilized. You can see this, the hummocks here, the sand hummocks are stabilized by the root system that is holding the sand together underneath the grass that you see growing on top of the sand too. The sand has been moving for centuries, and it's been, the better part of 100 years that beach grass and Scots broom were planted on the Oregon coast. And it's been in the last 60 years, really, that you have evidence of this, the brush band growing and becoming thicker. Right. And now it continues to just grow because the wind still blows sand, lowers the water table, and makes it more inviting for plants to find a home. Yeah. So, in summary, climate, shore topography, the fact that humans have intervened in the ecosystem has led to what we see here today.
So what would it look like if the beach grass never got here? How would it be different?
There wouldn't be any brush band at all because the sand could continue to move, and probably Highway 101 would be covered. These hills wouldn't be stabilized with trees. The end result of stabilization is vegetation can grow. This used to be, from what I understand, just dunes, and stabilization has occurred because of plantings. So I think the best example of that is just to go down to the Eel Dunes south of here and walk in until you're out of the forest, and you wouldn't be looking at this, you'd be looking at sand. But the sand stretches all the way to the brush band. So even though there's a lot of sand there, it's only the sand east of the brush band that is moving, and it moves and it takes over forest, and you can see that. You walk along the top of a dune and you have this steep slip face, and it's enveloping the forest. So sand can move in generally speaking, about a half an inch a day. I mean, if in really windy weather. So that's a lot of movement in a year.
Yeah.